In this video, we're going to use Microsoft Excel to complete a sensitivity analysis. We will be using this sensitivity analysis to understand how we arrived at an optimal solution for a linear optimization model that we put together. In the linear optimization problem that we solved earlier in the course, we were working with a company called Par Incorporated, which makes golf bags. And what we were trying to do is figure out how many bags need to be made between two different product lines in order to maximize profit. I won't go through that example as I did before. However, we will quickly figure out, based on the sensitivity analysis, some of the details that you would find when you do a problem like this. So what we'll do is we will rerun the analysis. So we'll go to our data options, and in our solver options, we'll have the dialog box. And because this is already pretty much set up the way we want to, I am going to go ahead and solve it again. And when I solve the problem, we end up with answers for each of the different products we had to make. If you remember the problem from previously, we had standard bags and deluxe bags. And what this is telling us is that we need to make 540 standard bags and we need to make 252 deluxe bags in order to maximize our profit, which would equal $7,668. Because there is a solution to this problem, the dialog box comes up and it tells us that we can either keep the solution or we can restore the original values. In this case, we're going to keep the solution. But here's where we get into the sensitivity analysis. Right here, the reports that we can choose from include an answer, sensitivity, and limit. So I'm going to choose sensitivity. And once I do that, I'm going to select OK. And what happens is Microsoft Excel creates a sensitivity report. And this is what it looks like. So we're going to blow that up so you can see some of the data in the sensitivity report. So what you see are the variable cells, and then you see the constraints. And what the sensitivity analysis is giving us is all of the data that basically says if we were to change some of the values by a certain amount, we would then have an impact on the optimal solution. So what it tries to measure is how much wiggle room you really have before you actually make it so that you do not receive or you do not produce the optimal result. So as we look at the variable cells in this first part, you can see here what I've highlighted are the values for each of the products. 540 standard bags, the deluxe bags, we need to produce 252, and the amount of hours consumed to produce the bags, we now have 0. So we're saying that it took all of the time we had allocated in order to produce those bags, which is exactly what we want to do. We want the hours to be 0, and whatever numbers come up here, we know that's the optimal solution. Reduce cost is all about how much wiggle room you have to reduce the number of these two variables before your optimal solution is having an impact. That's all that is, okay, in this column. So 0, 0, 0 means that we should not reduce either of these factors by anything in order to have a more optimal solution. So we have the best solution that we could have, is what that's telling us. The objective coefficients. As you go back to the formula, we said that 10 times the number of standard bags plus 9 times the number of deluxe bags times the hours, or better yet, times the number that we make gets to be our profit. So what we're saying is, so these are just coefficients of the objective function. The allowable increase and the allowable decrease, as I highlight these here, basically say that you can increase or decrease the number of products, in this case, that we're going to produce by so much before the optimal solution is having an impact. We can't increase or decrease the number of hours. So as you see here, you have 0 for the increase and you have a very small number for the decrease. Yet for the standard bags and deluxe bags, you have 3.5 and 3.7. That's how many more you can create or not create in order to still stay within the range of the optimal solution. For the constraints, you have a similar setup. Here are all of the constraints and the final values for those. You have what's called the shadow price. And all the shadow price is it just tells you how much the optimal solution can be increased or decreased if we change the right-hand side values or the resources available by 1 unit. So that's what that means. If we change the right hand by 1, then of course it goes up 4.375 for the cutting and the dyeing hours used. Or if we change it by 1, the finishing hours goes up by 6.9375 hours. So what it's trying to say here is if we were to change 1 unit of hours that goes into the production within the constraints of those products, this is what would change for the number of hours consumed for each one of these areas. Notice that the shadow price is 0 for sewing hours and 0 for inspection hours, which means we can't increase those hours at all. Here are the constraints, again, that we had. And basically what it's saying is we couldn't go over these values. And here are the increases and decreases for each one of those. Similar to what we saw with the products being produced. Yet, as I look at these numbers, this is basically saying we did not have a lot of wiggle room with sewing hours, and we didn't have a lot of wiggle room with inspection and packaging hours as compared to the other areas. So that is a sensitivity report in a nutshell. Basically what it does is it shows you how sensitive the variables, the coefficients, and the values are to change when you're trying to figure out the optimal solution.